Hey, welcome back. This is episode 20 of the Salesforce Agentforce Masterclass. Today, multi-agent orchestration and swarm architecture. Designing collaborative autonomous AI networks. Let's get into it. Here's what we're covering today. Introduction to multi-agent swarms and domain isolation, then, architectural patterns, peer-to-peer versus hierarchical orchestration, then, under the hood, agent-to-agent handoff and state management, then, loop prevention, configuring circular guardrails and TTL hop limits, then, enterprise debugging, trace routing and swarm performance monitoring. Stay for the last one, it's the piece most tutorials miss. Let me explain this simply. We are moving from single, isolated AI assistants to dynamic networks of collaborative agents. In this episode, we will look at how to design, secure, and debug a true multi-agent swarm architecture using the Atlas reasoning engine.
Wait, so agents can actually talk to other agents and hand off tasks? How do we prevent them from getting caught in endless loop traps or leaking sensitive CRM context?
Think about your business as a high-performing orchestra. Instead of training one massive, complex agent to handle support, sales, billing, and scheduling, we deploy a swarm of highly focused, modular agents. Each agent acts as an expert in its own domain, using the Atlas reasoning engine to process tasks independently. The true magic happens when these agents start communicating and handing off complex transactions to each other without human intervention. When orchestrating multiple agents, you must choose your architectural pattern wisely. In a hierarchical pattern, you have a primary coordinator agent that acts as the router, dispatching tasks to specialized subagents and consolidating the responses. In contrast, a peer-to-peer or decentralized swarm pattern allows agents to pass execution control directly to each other as the user conversation evolves. As a CTA, I recommend a hierarchical model for strict compliance and auditability, while peer-to-peer is perfect for dynamic cross-department workflows. Let's look under the hood at how handoffs actually work. When Agent A realizes it can't fulfill a request, say, a service agent handling a return that turns into an upsell opportunity, it initiates a handover to Agent B. This isn't just a blind redirect, it's a stateful transfer of the entire conversation history, extracted variables, and the customer's current emotional sentiment. Salesforce manages this securely through transient state payloads, ensuring the receiving agent doesn't lose a single ounce of context. In a multi-agent environment, managing state is the difference between a seamless experience and absolute chaos. If multiple agents are reading and writing to the same customer profile simultaneously, how do you prevent race conditions or state pollution? We solve this by leveraging shared memory fabrics, where the global session state is stored in a secure cache layer. This ensures that while each agent operates in its own execution thread, they all read from a single source of truth grounded in data cloud. What happens when Agent A hands off a task to Agent B, but Agent B decides Agent A is better suited, creating an infinite loop? This is a classic infinite recursion risk that can drain your API budget and freeze customer interactions in seconds. To prevent this, we must configure strict multi-agent guardrails, including max hop counts, circular reference detection, and cooldown periods. Think of it as putting a time to live on the conversation metadata so the system automatically alerts a human operator if agents get stuck. A swarm of agents is only as smart as the data it can access in real time. If your service agent operates on stale ERP data, while your billing agent uses live Stripe data, the swarm will contradict itself, destroying customer trust. By grounding your entire swarm in Salesforce Data Cloud, every agent accesses a single, unified profile. When one agent executes a tool and updates a record, that change instantly propagates across the vector database, giving the entire swarm real-time, shared context. Debugging a single agent is easy, but tracking a conversation that bounced across 3 different agents is a massive enterprise challenge. We use the Agentforce simulator along with advanced trace routing to visualize the entire path of a transaction. You can see exactly which node triggered the handoff, the prompts passed during the transition, and the latency of each hop. For production monitoring, we stream these execution traces directly into event monitoring dashboards to spot bottlenecks and optimize performance. To tie this all together, let's review the ultimate CTA blueprint for designing collaborative AI systems. First, design for isolation. Keep agents focused on single domains to optimize accuracy. Second, establish standard schemas for handoff payloads to ensure seamless communication. Third, secure your data boundaries by mapping user permissions to the running context of each subagent. By treating your agents as modular, governed services, you can scale your autonomous workforce safely and predictably. Alright, let's wrap up. Here are the key things to remember. Multi-agent swarms rely on domain isolation, where specialized subagents coordinate instead of a single monolith. Architects must choose between hierarchical, predictable, supervisor-led, and peer-to-peer, dynamic, direct handoffs orchestration patterns. Loop prevention guardrails like max hop limits are critical to avoid infinite conversational loops and runaway API costs. Data Cloud acts as the shared, real-time context backbone to ensure every agent in the swarm references identical, unified profiles. If this helped, hit like, it really helps the channel. Next up, this completes our Advanced Agentforce series. Keep building, keep securing, and scale your autonomous workforce. See you tomorrow.